Stuart here. Today we're going to talk about quality management and moving quality left with accountability. So we need to start out with a definition of what quality is, and there are lots of different measurements. But effectively, quality is the measure of the difference between the delivered value of the system minus its debts. And it's a lot like any other value proposition or value statement, right? You take the good things and you subtract off the bad things, and what's left is the value that you deliver, and the gap between them is the potential gap, potential value. One of the statements that is absolutely true is quality, like security, you just can't bake it in after the fact. I've seen a number of enterprise projects and our company's seen a number of enterprise projects where they allowed technical debt to build to the point where they simply had to do an emergency remediation. And the cost of that remediation and the fact that they were forced to do it at a time of someone else's choosing, that is to say, they had an incident or a disclosure, or they had a loss of reputation, was far more damaging and expensive than if they had embraced modern DevOps and, like many other procedures that go with DevOps, tried to move quality as far to the left, that is to say, as early and often in the process as possible. And these ideas, they're not new. They go all the way back to the early origins of the space program. And my favorite, easy to understand, clear to explain to all stakeholders is total quality management, which is comprised of three kinds of activities. We test, we inspect, and then we look at the results of testing and inspecting, and we analyze, and then we act. That is, we do something about what we found out as a result of testing and inspecting. And if there is a failure anywhere in the quality process, it's that a lot of teams do one of two equally horrible things. They either start out and they write everything down, but it doesn't stay current, it doesn't get updated, and after a while, no one looks at it and no one cares about it. Or they start in chaos and they say, look, this is all a POC and it's all experimental and none of it's going to go to production. So we're just going to try to figure out a bunch of stuff really fast. And then, we're going to productionalize it. And that is a terrible word, productionalize, because A, it's not a real word. And B, if you don't start out with quality and security, you backing it back in is a traumatic experience. So you have organizations that are very governance oriented because they have various compliance procedures they have to follow. They need to be auditable because for various reasons, they need to be able to report that they're doing the things they said they're going to do. And the problem with that is it becomes a goal in and of itself that has nothing to do with delivering business value and everything to do with satisfying their shareholders or regulators and potentially not even adding any real value. So the takeaway from what I'm getting at here is that if you're going to have standards and governance and you're going to write them down because you need to write them down, if they're not backed up by automation, in fact, it's worse than not having any at all, because you have the illusion that quality is happening without the actual proof that quality has been done. And a consequence of that is that in a modern organization, that the automation comes first, and that we extract from the automation what effectively the governance standards are, because those are the ones that are really being enforced, right? We have automation and it's doing things and it's producing outputs. And so the things, documenting the things the automation is doing from inside the tools themselves is actually way better than sitting down with a blank piece of paper and writing a bunch of stuff down. And what's more importantly is, as you tune that, as new versions of the tools come out, as you develop new policies and procedures, your business finds new challenges and you're forced to adjust your automation, that you can then regenerate your governance and process documents from the tools themselves. And so they're always relevant and auditable. And so a really mature organization, the standards and governance is set in the tooling and then documented as part of the operational procedure that goes with the automation. So here's a planogram for total quality management and DevOps. And we divided it into 4 value columns. All of them are important. All of them should be implemented to one degree or another. The decision about where to invest in tooling, because even open source tooling is not free. There's a human cost in evaluating things, in implementing things, and there's a human cost in looking at the output the tools produce, acting on it, right? If you don't have action, then nothing changes. And there's a saying that nothing changes if nothing changes, and it's a syllogism for quality improvement programs. That is to say that the definition of insanity is repeating the same behavior over and over again and expecting a different result. So unless you couple action as part of the total quality management, and in fact, you prioritize acting over everything else, your efforts to have better quality and security will not be as successful as they could be. So let's start left to right and talk about various things that you can do. And almost no one does all of these, but you could. But these are, in each category, the 5 things that we as an organization have found to be the most effective. So starting with the developer, that is, the people who are producing software that drives business value for your organization, right? If you can get quality in from the get-go without cycles of correction, because to some degree, this represents a left to right progression of time as well. So if we can get an experience, whereas developers work, they get tricks and tips and hints and warnings, this isn't a good idea, do this instead, and so on. And almost every single modern integrated development environment has tools that plug into it that literally put a little light bulb next to lines of code that fall short of an expectation related to security, quality, or both. So that's the first line of defense. Like, as developers are typing code, they get warnings about what things that they're doing that are not optimal, and they get the opportunity to click on something and have it be corrected. And then as they're corrected, what we find over time is that the number of times they're reminded to correct something goes down, generally precipitously. And so out of the gate, you have met some minimum quality bar by following the best practices of the programming stack you're in, because you're getting feedback immediately as a developer as you create code. The sidecar to that are testing tools. So, whether you do test-driven development or test with development, or you code a little, test a little, check in, code a little, test a little, check in, which is my favorite approach. The testing tools that you use are important. And parenthetically, most of these tools and things are open source. And so, can you buy commercial versions and get support and a throat to choke and professional consulting? Absolutely. But these days, a lot of these things are available as sort of table stakes as part of the open source community. Linters are tools that run outside of the IDE typically, or sometimes they're called by the IDE and then the output appears in a window that says, looking at the totality of your code, here's some things to be concerned about. It's not necessarily as immediate and tactile as being warned by your IDE with a little light bulb or a red line, but linters typically have deeper depth, as do vulnerability scanners. So linters are looking for syntactical and semantic things as part of your programming language, whereas vulnerability scanners typically prioritize patterns of code that are known to lead to vulnerabilities. And best practice analyzers are sort of a tool above that, a meta tool that actually looks at either the configuration of a third-party product like the SQL Server Best Practice Analyzer, or they look at how you're using that product with code and giving you advice. So the SQL Server query monitoring tool is a nice example of those. Like, the developer is asking for 1 million rows to come back to this UI. Probably not a good idea. So that is as far left as you can go, right? The minute that the developer's fingers hit the keyboard and everything around their daily cycle of activity is that as far left as you can go. But it's not where you should stop, right? Because what's missing there is visibility to stakeholders, which is at the far right of our continuum. And so there's value in the developer group. The next group is the pipeline group, and that is your organization should have a centralized source control. When developers check in code, it should be compiled off the developer's machine, and tests should be run against it, and code scanners should be run against it. And you should have a process around humans reviewing the code. So pull requests are this sort of state-of-the-art how most software gets developed by teams. And you should be able to deploy your software to different environments and then undeploy it and roll back to the previous version. And that should be friction-free to obtain the most quality. And from the pipeline activities, we get the next level of visibility. That is to say, the people who are on the immediate project team, so developers, QAs, PMs, BAs, product owners, right? They're seeing the tempo of the pipeline executing at really regular intervals. And in mature shops, they see it many, many times a day. So then your code goes off and hits infrastructure, right? We go to our environments, dev, QA, UAT, prod, maybe more than that, maybe fewer, but 4 is kind of the magic number of kind of what's minimum in terms of having environments that serve a purpose, right? Dev is for dev integration to make sure that the developer's developing different parts. When the parts come together, that they play nice. QA is where well-baked things go to be tested. UAT is the place where business and customer stakeholders have a chance to look at the operation of a system before we say, yeah, that's ready to go to production, and then there's production. And production includes, your disaster recovery environments and all that other stuff, just to simplify it. So to support that infrastructure, right, that code running in environments, that's the infrastructure, we need 5 pillars. We need network scanning, which is normally fairly invisible to developers and other stakeholders, but it shouldn't be. And what does network scanning give us? It says, what are the traffic patterns between different components? And should A talk to B or not, right? We should know whether A is talking to B. And if A is talking to B, is it doing so efficiently or inefficiently? If we have a big network that's shared as a shared resource, as we do in the cloud or in the data center, is application system 4 eating up all the resources, and are they eating up resources in proportion to the value they're delivering, right? Do we have enough resources? Do we have programs that are running in competition with one another that in fact are impeding either of them being efficient? So network scanning, infrastructure monitoring, those are all key tools to watching how the deployed systems behave in the real world and getting insights into them and hopefully getting out ahead of them. And then there's 3, they're part of the security story too, because if we see weird traffic or bizarre things happening from infrastructure monitoring, if we have a really well-run system, even if it's just humans giving things the eyeball, someone will go, that's not right. We need to investigate that. And then we have, traditional infrastructure networking things. So we have an activity penetration testing and the output of that. We have intrusion detection, which are passive tools that monitor the network, especially from one network zone to another, like the public to the DMZ to the private network to the data tier. And they're looking for, again, using AI to look for ill-formed patterns of interaction. And of course, we're fundamentally protecting our network at all layers using web application firewalls in between different trust zones and firewalls in general everywhere to only allow the traffic that we want. And then we have the analysis pillar. And the analysis pillar is automation that supports the creation of metrics that can turn into key performance indicators, which in turn can cause a trigger which would feed into your monitoring, logging, and alerting system and tell you that something is not right. So typically, in a perfect universe, you have an MLA tier that is used, that everything feeds. And it will tell you for things that are running if there's a problem or an incident. But in order to get visibility into likely behavior, we have the testing activity, right? So QA, UAT, synthetic transactions, all the things we've talked about in other videos. And we also want to get a sense for how our systems are actually being used by consumers. Because the one thing I'll tell you after a lifetime of being in software is that users find new ways of using my systems I never anticipated. They're not bad things necessarily, although occasionally they are. But if I know that, I also can then feed my backlog, my engine of delivering business value with insights from behavior tracking to go, it's taking them a long time to get done what they want to get done. And here it looks like this is the thing they want to get done. Could we make that easier? And then you want pane of glass visibility throughout the whole entire thing, the river that runs through it. And there are just a bunch of tools for doing this. And in the Microsoft universe, right, a lot of these things are built into Azure. And the pane of glass visibility tool that's the easiest to use is Power BI. And almost every single one of these boxes is in the Microsoft toolkit somewhere. So Visual Studio, MS Test, various things. There's an ecosystem that of third-party products that plug into all these places and give you extra value. The thing is, it's easy to get wrapped up around the axle of tool selection. And what's more important than tool conformance or everybody being on the same tool, or this group goes and gets an exception because they like this tool better than that tool, is be focused on the goal, right? The tool is less important than whether or not it hits a TQM goal, which is to reduce the gap between a system's potential and its actuality. That's the definition of quality, right? And so I've seen a lot of organizations get wrapped up around the whole argument about this tool versus that tool. And I can tell you as a guy, I couldn't care less from the point of view of managing a large, complicated program. What I care about is that there are tools, that people use them, and that most importantly, they act on the things the tool is trying to tell them. And if we get down the road in our planogram and we're discovering defects or problems or other quality issues, and it transpires that if we look at the tool just missed it, we can either give the vendor or the open source community the feedback, or we can adopt different tools, or we can adopt additional tools. But if you never looked at the output, that's the will to use them, and then acted on that, then you can have all the tools on the in the universe, and they won't impact quality at all. So the problem with compliance programs is they say, thou shalt use the XYZ tool. And then they have a generality about how often you should look at it and what you should do when you find certain things. But those are so either incomplete or overly restricted or hideously complicated that it removes the basic humanness from the equation, which is some person who understands the problem domain has to look at a single pane of glass and say, is the gap between our potential and our actuality acceptable in terms of the risk and the value that we're delivering? And a sign of dysfunction, right, is the unwillingness or inability to maintain a quality program. But even more telling is the inability to realize the benefits of that program. I've seen so many organizations that have all this ornate governance. They bought all these really expensive tools. They go through all the motions of acting in ways that are supposed to improve quality or security or both. And yet they fail to realize the benefits because they fail to do the essential analysis, which is what are the risks, what is the cost to remediate the risk, and what is the benefit? And if you're not realizing the benefits of your quality program, and if, in other words, if you're not adding business value or reducing risk, then your program is dysfunctional. So here's a little checklist that I use when I'm coming into an organization and I want to understand the state of maturity of a quality program. And by the way, you don't have to eat the whole elephant in one sitting, right? We have another video that I like to call pain-driven decision-making. And you can increase quality in increments by slowly introducing these tools, but you've got to make people care about looking at the output and acting on their advice. And if the tool's advice isn't worth acting on, then you've either configured the tool incorrectly, that is, you can just turn that rule off, or the tool's not useful for your use case. So adopt something in each of the pillars of the planogram, including that pane of glass at the bottom. If it's manual, try to automate it. If it's watched, You got to specify and then follow up to validate who watches. Because if it's some nebulous, the stakeholders will blah, 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 most useless statement and requirement spec I've ever seen, right? A named group led by a named person has to be held accountable for any program to be successful. So if it's vague, it's not going to help. And push left, hold developers accountable through automated tools, testing, and metrics that are visible to everyone. There is nothing more sober to a developer than a dashboard somewhere that shows the overall quality of the program group they're in, and they drill down into their swim lane, and then it drills down to them, and it has quality and security metrics as a score. And then it has a color, traffic light, right? That says you're above the average, you're at the average, or you're below the average of quality and security. And that makes it very easy for line managers to hold people accountable. Like, this is in the red. Why is this in the red? Well, because this swim lane is in the red. Why is the swim lane in the red? It's because this team isn't doing the right things in the right ways. So quality early and consistently applied beats down technical debt. You can't wait for the end of a sprint to start working on quality, right? You have to have a really effective program, right? They need that immediate tactile feedback. You need CI builds that kick off every time somebody checks in, and people need to check in a couple times a day, right? The higher the velocity that you're seeing things, and the smaller the granularity, the better shot you have at finding something early and remediating it, right? And reducing debt reduces risk and increases quality, and increasing quality increases velocity and delivers real value faster.